Hello, on this video I'll be looking at how to calculate outliers, and we'll use two different methods, the standard deviation method and the IQR method. I'm using the same set as I have in previous videos in this section, so I'm just coming right where I left off before. I have two sets, the AP Stat class grades from last year and from 2020, and my geometry class grades from 2020, and I did one variable stats on them already. I'm going to need a couple things. I need the standard deviation. Normally you use the first one because we normally are doing samples, but you could use the second one as well. Either one, they're so close that it really isn't going to matter which one you use. So 0.11, and you could even, kind of go in the middle there, but let's use this one. So I'll use 0.1136, I guess, and then also I need the mean for that, so 0.8318, and just, maybe 4 decimals or something to get yourself going. In my other set, I have my mean of 0.86 and my standard deviation of 0.0829. So those two numbers are for the standard deviation method. Let me just do them over here on the side. We can all see this okay. And I can, you could do this by hand, of course, or you could, if you wanted, like just open up a calculator page and do all your calculations here, if you want. But you could also just do it right here in the spreadsheet, right? You can do your calculations. So basically all you're going to do is just go up and down 2 standard deviations from your mean. So that's a pretty simple calculation. I'm going to say equals, let me take this, and I'm going to go down, so I'm going to minus 2 times my standard deviation, this number. And you can just click on the cells. You don't have to type in the numbers or anything. Hit enter, and there you go. This is what we call lower bound, a lower boundary. And then let me go for the upper bound on that one. So equals my mean. And I will add, this time, 2 standard deviations. And again, I'm just clicking on cells and hit enter a couple times, and that's your upper bound. So my lower bound was 60%, upper bound 100%. So when I look at my graphs, I can see that, I don't have anything below 60%. So that's why no outliers came up. And I don't have anything above 100%. That would be impossible anyway. So no outliers. You can also look at your set of data and look at it that way. And if you're like, oh, this is really cumbersome to look through to try to figure out, what's the lowest number and what's the highest number, you don't want to look through all those numbers like that, you can highlight your whole column. You just scroll up and keep going up until it highlights. And then what you can do is in the, I think it's in the actions. Yeah, in actions, there's a little sort button right here. So I can hit sort, and you can set it up however you want. I'm starting at the lower and going to larger and ascending. Okay, great. Just hit that and it'll sort your data for you. That's not going to change your statistics. That's not a problem. Sometimes if you have data that you're trying to correlate, then you don't want to do that. You got to be really careful because the numbers are connected to each other in a pair. But in this case, this is just one set of data, so I can go ahead and do that without messing anything up. I can see my lowest number is 0.606 in the list, which is higher than what I had calculated. So it's not an outlier. And then you could also do the same thing on the other end, right? I can see that my biggest number is 0.99, which again, when I look at my upper fence, my upper boundary, I get 105%. So I don't have an outlier in that first set. Let me do the same thing in my second set and see how that comes up. I guess I'll just do it on the side over here. Same thing, but now I'm using my geometry set. So take the mean, subtract 2 standard deviations. Again, then take the mean, and this time I'm going to add on 2 standard deviations. And I get 69 up to 103%. This started at 67, so like in this method, this should have popped up as an outlier. But here's the thing, the TI Inspire uses the IQR method when you are graphing box plots. So it's using the IQR method to find outliers. It doesn't use the standard deviation method. When you have skewed data like we have here, the standard deviation method that I'm showing you here is not as reliable. The standard deviation method should really only be used when you have like nice symmetric data. If your data is not symmetric like we have here, you don't want to mess up your calculations by having like really skewed, not like really big numbers or really small numbers or too many numbers in one grouping or whatever. It's going to mess things up. It's not really representative of what you have. So we don't use that method. We use the IQR method instead. So again, this was 0.69. And when I look over here, 0.67 is below that. So it should have been, well, it is an outlier using the standard deviation method, but we shouldn't be using the standard deviation method because it's skewed data. Okay. Again, on the upper end though, like, 102% is way over here. So this wouldn't be an outlier. So we would have one outlier with this method. It just isn't a good method for this data set. So let's do the other method. So what I need first is the IQR. I'm just going to label that. Okay, so I remind myself, this is my IQR. I'll just do it right here. So the IQR is just the the third quartile minus, I got to click back in there. It's a little annoying, but you got to do it. And then hit enter. So that's the IQR for the first set. And then for the second set, Q3 minus Q1. And you hit enter, and there you go. That's your interquartile range. You can use this as a measure of spread. We're going to use it, though, to calculate outliers. And then your next step to get your fences, your outlier fences, is to take your minimum. So your minimum, I'm sorry, take that back. Take your first quartile, and I'm going to subtract 1.5, 1.5, times the IQR for that set. All right, and then that gives me my lower fence. Now let's do the upper fence. To do the upper fence, you start with the third quartile, and then you add on 1.5 times my IQR for that set. So you're going down from Q1 and going up from Q3. So that's your lower fence and your upper fence for that set. Notice how this is 0.42, much different than 0.6 that we got on using the other method. So different methods will give you different fences for your outliers. Okay, let's do this set. So I'm going to take my Q1 and I will subtract 1.5 times my IQR. Should be these, right? F9, right? Okay. And then for my upper fence, I'll take my Q3 for that set and add on 1.5 times my IQR for that set. Gotta be careful you're using the right numbers and stuff, right? Like I said, you can always just go to the calculator page and type it there in a calculator and calculate manually that way. Either way, you're going to have to calculate it yourself. It doesn't automatically pop up anywhere. You do have to do it yourself. You need to know how to do both of these methods, and you need to know when to use each method. The IQR method is almost always a good way to go. So this is what we normally will do. We'll use this IQR method to get our fences, and you're almost always safe doing it that way. So if you're not sure, then use the IQR method. One thing a lot of people ask is, why don't we go from the median? It's just the way we do it. Remember, when you're working with quartiles and stuff, you're looking at percentiles, and you're not using every single data point. You're just kind of cutting things into groups. So you're kind of going from this group, how far away? And the other question we get a lot, like, make sure you're not going from the median, because before, when we did the other method, we actually went from the mean, right? We used the mean to get this. But in this case, we don't use the median. We use the quartiles to do it. So be careful with that. The other question people always ask is, why is it 1.5? When we did the other method, we used 2. Like if we look up here, we did 2, right? 2 times that standard deviation. So why is this 2 and why is this 1.5? Well, that kind of goes along with up here. We started at the mean. So we need to go a little further out. So we use 2 standard deviations to go a little further out from the mean. Here we did not start at the median. We started at the quartile. So we don't have to go quite as far out. So we don't use 2, we only use 1.5. And they actually asked the guy who invented this and said, why 1.5? Why didn't you use 1, or why didn't you use 2, or why didn't you use 1.63 or some other number? And his answer was very simple. He just said, well, 1 was not enough and 2 was too much. So 1.5 is right about where you're going. Now, why wouldn't he use some precise number like 1.6 or 1.73? Well, the whole idea on outliers on statistics isn't to come up with a black and white definitive borderline. It's just a tool for you to identify data points that need a closer look. So if you have a data point that's outside of these fences that you calculate, then you just want to take a closer look at those and ask yourself, why are those different? It doesn't mean they're bad data points. Usually they're still good data points. Once in a while, you'll find out that you collected the data wrong, or you forgot to put a 0 on the end of a number, or something like that, where it really is a bad data point. But most of the time, it's nothing wrong with it. It just is what it is. So you just want to take a closer look at that and find out, why is it so unusually large, or why is it so unusually small? It's just something that can affect your whole data set. It can affect your analysis. And it's just a way to figure out which one of those points you should be looking at to see if there really are outliers, right? So it's just a tool. So 1.5 is fine, right? Okay, so let me go back. Let me just do one of these sets. So this is 0.667 on my geometry set, 0.667. I think I can put in a movable line here. See how a movable line pops up on this? And I can, a lot of times we will try to put this right at our boundary. That's close enough. And that will help me see where my outliers might be. So 1.09 was my upper end. So if I go to my tools and analyze, I can add another movable line. And you can just move that, grab it and move it. 1.09 is like way up there somewhere. I got to move this way over even to be able to do it. I think it was 1 point. It's way up there. Isn't that what it was? Yeah, 1.091. So that's like way up there, right? So you can see from my quartile I went down 1.5, and from this quartile I went up 1.5. The distance from this quartile, the third quartile, up to the fence should be the same distance as your distance from Q1 to the lower fence. This tail ends up being really close to it, but this tail was not close to it at all, right? So it was close to have an outlier, and you might even say, well, this was really close to being an outlier. In the standard deviation method, I would have had an outlier, maybe for this other set, right? Stuff like that. So maybe there is a data point there you want to kind of look at and analyze and figure out why it's so small, right? Like, this is my geometry student, so I want to take a look at that geometry student and say, hey, why did you have such a hard time in my class, and what can I do to improve my class to make sure other students don't struggle like you did, right? And things like that. So it's just a tool to identify those outliers to help guide your decision-making process in whatever you're doing. Okay? All right, that's it for this video. Look at all the other videos in the section to find out more.